So let's go ahead and make sure this is all working. All right, so 6, enter, 5 times, that's 30, that's good. How about 47 plus 77, excellent. How about 2 divide, 38.5, we're seeing the floating point number there working. You can see the stack is doing all the right thing. Okay, makes sense. Now I'm going to do one more thing here, which is to add another operation. This is going to be a slightly different operation. So I'm going to copy and paste these operation buttons here. Again, I'm going to make sure they're lined up really nice with as many blue lines as I can get. I'm actually going to leave these buttons here because you're going to need them for your homework. But we're going to change this button right down here to be a different operator, which is going to be square root, which is right here. It's the square root operator. All right. And so I'm going to go back here to do square root, and it's just another case, right? Case square root. And maybe I should just be able to use this same mechanism, right? Let's see if that works. Paste that in there. And instead of this subtraction here, let's use the built-in function in Swift to do square root called square root. And we did $0. Looks good. Yeah, we're ready to go. It should just work, right? Oh wait, what's going on here? We have some sort of error. Why? What's the problem? I don't understand. Let's take a look at this. Now, this error is a little hard to understand, but basically what it's saying is that you're calling perform operation here with an argument, which is a function that only takes one argument. Because Swift looks here and it sees that it's only using $0, so this is a one argument function. This whole curly brace thing is a function that takes one argument. Well, perform operation takes a function that has two arguments. So that's a mismatch. That doesn't work. So how can we fix this? Well, actually, believe it or not, we can just make a copy of perform operation of another method, same name. This one's going to have different arguments. It's going to have an argument, which is a function that only takes one double and returns a double. And then inside here, obviously, we don't need to pull two things off the stack, just one. And obviously, we only need to check to make sure there's one thing on the stack. And look, all errors, warnings gone. Okay, Swift automatically figured out that this perform operation must be this one because this is a function that only has one argument, and so it matched it up with this version of it. So in Swift, you can have functions with the same name. They can, as long as they have different arguments, and Swift will automatically pick the right one if it can. There are some times when it's just like, I can't really tell which one you mean, and it will certainly complain in that case. But most of the time, it's going to be able to tell from the types involved what's going on. So let's go ahead and run this one again real quick. 36 square root. Looks like it's working. 9 times square root. Excellent. Okay. All right. So the last thing I'm going to do here is work on the layout of these buttons. So that's all I'm going to do for the code. You can see that we really didn't have to write that much code to make this work, and we got to do a lot of stuff in our UI here. So let's go ahead and make it so these buttons spread out, because right now you see all the space is wasted right here, and on an iPhone in portrait mode the whole bottom space is wasted, and in an iPhone on landscape mode this whole side is going to be wasted. So I really want these buttons much bigger and stretching out. Now when you do something like that, you have to think a little bit of kind of what your strategy is going to be. You can't just kind of brute force start, control dragging between things and trying to set up the horizontal spacing and maybe line up and maybe make them the equal width and height. Oh my gosh, you'd be control dragging all day long doing that. So I'm not going to use control drag to do this. I'm going to use these buttons down here, which are kind of bulk auto layout buttons. Let's go ahead and use the whole screen here, document outline. So what is it going to be my strategy? Well, my strategy is I'm going to make a perfect grid here. So I almost have one, except for there's one missing here. So I'm actually going to take a button, copy and paste it, Okay, just kind of be a dummy button here actually with no title. I'm going to right click on it also because I don't want it sending a pen digit or anything else, so it's not going to send any messages. But it's just a dummy, so I'm kind of using a little bit of brains over brawn here to do this perfect grid. Now if I have this perfect grid, then if I had a rule where all these buttons had to be the same size and they all had the same spacing between their neighbors, not just between each other, but the same spacing to this edge and the same spacing to this top edge, okay? If I had a rule like that, then they would get big, and of course this same spacing from this edge to this edge and this edge to this edge. If it's all exactly the same, which I'll make it be whatever this is, whatever the blue dashed blue lines gave me, if that was the same, then they would all have to spread out. Okay, they'd get bigger, but they'd all stay the same size because I'm going to make a rule that they have to be the same size. But they would move out to this edge so that this nearest neighbor would be the same, this distance would be the same as this distance. So that's my strategy. I'm going to try to do that. Now, to make that work, all these buttons need to know who their nearest neighbor is. Well, these all know their nearest neighbor here, the other buttons, because I made sure I used dashed blue lines when I dragged them in there. So that's what kind of teaches them the nearest neighbor. And I'm also going to make sure that the entire grid knows that the left edge and just under the label there are the nearest neighbor. So now it knows on the top the nearest neighbor is the label, and on the left is this edge. And it's going to pick this edge as the nearest neighbor for these buttons and the bottom edge, because that's all there is. There's nothing else out here, so it kind of that's the only neighbor there is. It's going to pick those. So now that I've kind of used my dash blue lines, it makes this all quite easy. Now if you don't use the dash blue lines, or if you kind of make some mistakes, then this is not going to work. This strategy won't work. And I've made doing this part of this demonstration be extra credit. And so if you can't get it, don't worry about it too much. Just keep all your buttons in the upper left corner here, and that's fine. But if you want to give this a try, the key is to use the dash blue lines to make a perfect grid. Make sure that you set the nearest neighbors here by dragging the whole grid to make blue lines appear on the sides. And then we're going to set these rules in bulk, and we do that with these buttons down here. So there's this button right here, the leftmost button, and it lets you set things like lining up leading edges or the tops or the centers. And you could imagine there might be a way to do this by doing that, but I'm not going to use that strategy. My strategy is to just make them the same size and make the spacing between them be the same. But I bet there's probably a way to do it by lining up their centers or something like that too. So I'm not going to use this one. The next one over right here is the one that has the things I want. And so you can see that it allows you to make all the buttons equal width and height. Okay, not width and height. That fixes them at a certain width and height. This means that they can be any width and height they want, but they all have to be the same width and height, all these buttons. Of course, I have these all selected, by the way. If you don't have them selected, it doesn't make any sense. And then up here, you can see there's spacing to nearest neighbor. So this is where I'm going to set that spacing between all of these to be the same. And you can see that it's put 8 here. That's because when I did the dashed lines to the top, 8 seems to be kind of a standard number of points between elements. These are all multiple because some of these buttons, their nearest neighbor is way over here, and it's huge, right? The bottom or their right. But all these buttons, the thing on top, whether it's another button or whether it's this label, all of them happen to be this 8 points right here. So I want all these to be 8. So I'm just going to turn this bar on right here, which says, yes, please enforce and make the rule that all of these are 8 points from their nearest neighbor to the top, and also 8 to the left, 8 to the right, and 8 to the bottom. You really want to make sure these beams are on. If these beams are off, even if there's a number here, then it's not going to add this rule. So we want it to add this rule. So this adds up to 87 different rules. All these equal widths and heights, and all these sparing neighbors. So if you don't have 87 in here, if it says 100 and something, whatever, probably you don't have everything lined up right, because it only takes 87 constraints to express all these rules. All right. Now, when I click this add 87 constraints, it's going to add these rules to all these buttons, and watch what happens. So I get all kinds of, first these blue lines are showing me the rules.